Hi everyone, Andy Perry from Energy Systems Catapult. I'm a career civil engineer, so this is right up my street. So 15,000 heat networks in the UK, give or take 10%, depending on who you speak to. Who knew? A lot of people don't know there's that many in the UK. Around about 10% could be considered district heat networks, with the rest of them being shared heat. So it might be worth considering a difference between the two. Shared heat is more along the lines of a building scale or a small residential scale, where you're looking at a single energy centre producing energy for a single building. And then when you're looking at district heat network, you're looking at linking those sort of community heats together with sort of transmission and distribution scales. So we're gonna focus quite a bit now on the network scale, and we look at the system architecture of this network scale. Essentially, they're both the same, whether it be shared heat or networks. You've got a source pathway and a target. So on a community scale, you've got an energy center, probably a CHP or a gas boiler, producing high temperature heat into a distribution network for the building that powers your space heated domestic hot water. That system architecture is effectively the cellular heat network, where you might have an energy sector such as an energy from waste plant or a large commercial scale heat company. But again, you're into large distribution, the infrastructure Sarah mentioned, into a street by street and a house by house level. On that larger scale, that infrastructure, that target is generally up till now has been primary off-takers associated with public sector buildings. So you need those anchor loads in order for the commercials to stack up the energy generation and distribution size. So why heat networks? What are the benefits? We can see lots of benefits. We're focusing here on National Retrofit Hub on social aspect of making the energy system more democratic. So the first thing is, if you haven't got fuel, then you can't be in fuel poverty. Heat networks, or heat as a service, can actually offset that fuel poverty vector that we're also worried about. So that's your affordability. And scale, you can look at flexibility as well. Systems balancing, because you've got large scale storage, you could be offering flexibility services. There's also resilience to price shocks, as long as you have disaster recovery plans in place. Otherwise, things could get really expensive. And of course, we've got this overarching problem: how do you decarbonize dense urban areas? And heat networks is an amazing solution for decarbonizing these areas. So what's the current state? Current state of heat networks. Internationally, we've got 50% all sort of domestic and service buildings in Finland, with the heat demand met by heat networks. 90% of buildings in Stockholm with the heat demand met by networks. 98% in Copenhagen. So there's a really good international precedence here. What's the state in the UK? I think underrepresented could probably be the summation of that. 3% currently, or to get towards 3% of heat demand provided through networks. It's becoming more attractive to do so, and indeed, operators and whatnot are being compelled to do so because the economic spreads, CHP and fossil fuels, are not adding up. So, how do we get to the Climate Change Committee's target of 20%? So 20% of all UK heat demand delivered by heat networks by 2050. That's a big ask, but plans to be put in place. Strategically, a national strategic infrastructure allows the government to make decisions, to actually delegate, to take planning decisions away from local authorities and designate nationally significant infrastructure. This just happened in Bundop. We've also got local authority planning authorities. The planning control are actually being told to beneficially consider any projects that lower carbon and head us towards our decarbonisation targets. So those are important policies in place. How do we do it? How do we get there? Like I say, the economics of fossil fuels are adding up now. So we've got electrically powered heat pumps, that's clean. We got waste heat, which is coming online and is a big focus for future work, and even possibly hydrogen event further down the line. We've got barriers as well there. Some political and regulatory barriers are still in place. things around accreditation for new technologies to get into the system, tariffs that local authorities would be in charge of electricity usage. Some of these things need to be overcome to actually lower the barriers and accelerate deployment. Economically, they're very, very capital intensive. Investment confidence isn't necessarily high. We're looking at internal rates of return at about 5 and 10%. Investors famously and understandably prefer lower risk of higher returns. Heat networks aren't quite there yet, but subsidies are making them edge that way. Socially, people don't understand. I think we can see that generally as public, we don't really understand heat networks, and also we got concerns about affordability. So, is it fair and is it affordable? Technologically, really complex. Supply chain is complex. There's a lot of coordination. We got limited uptake of international precedent. We haven't learned a lot from just across Europe. And one of the big problems is called the levelized cost of heat. What you see is investors want to invest and operators want to operate. But we can't quite get the heat down to a cost that's comparable with gas. And if that's the case, you can't rely on the off-takers. You've got a connection risk. If you've got a connection risk, you've got an economic risk of people will invest on. Big problem. So we have drivers. There are drivers. Energy from waste generally represents some of the largest producers of heat. Local authorities have a statutory mandate to dispose and manage their waste. They quite often do this by contracting out to large energy from waste operators. Energy from waste, they could burn the waste, they manage the waste on behalf of the local authority, and use that energy to produce electricity and sell it. It's a nice a revenue stacking opportunity. However, the energy generated from waste and some of the dirtiest on the grid now, and it's coming under a lot of pressure from wind and solar. So much so that the emissions trader scheme is going to pick it up in 2028. That really changes the game. So the operators are going to want to charge the cost of compliance to local authorities. There is some talk about carbon credits, and if you can offset carbon-intensive heating by using your energy for waste, there's a chance that these things could wash their face. It's really going to be a driver. Another driver of the industry is minimum energy efficiency standards for commercial builders. So we got some big projects. You got the South Westminster area network. We got Bristol through VAT4, who's seeking to power 15% Bristol. You've got Bolton, Leeds, Plymouth. That's £1 billion in procurement moment. Then you got Sheffield, Trafford, and Stockport. Another £1 billion going to procurement for the end of this year. So you got the budgets in place. You got the policies in place through Planet. You've got, you actually got probably the biggest barrier to this now will be skills, and I'm sure it's something that we'll speak about. We got a burgeoning industry, and we haven't got the skills to be able to populate the growth factors that are coming our way. So, in summary, I think we, at the end of this talk, I've tried to keep it very high level because the guys following me would go incrementally down into the detail. But I think we'll see that heat networks are going to be an integral part of decarbonisation for the UK towards our 2050 pathway. Thanks. Here you go.
Yeah. We're a little bit out of sync because we're missing Camilla today, but...
Hello. I'm also Andy, but for the purposes of today, I'm Andrew. So if we're giving questions, direct Andrew and but I'm Andrew Pinches, the operations director at Rossendale Valley Energy, and I'm going to take us, as Andy said, way down to that stream now. So we're looking at decentralized individual heat pumps in properties. We've got an Innovate UK funded project at the moment called Net Zero Terrace Streets, where we're looking at essentially what happens in a community where a centralized heat network is never going to be, well, in the next 50 years, isn't going to be there. There's no anchor loads. There's no buildings, what kind of these heat centers or the kind of generation needed to all this to properties. So we're designing a street by street, modular, replicable, scalable model that could be lifted and shifted across the country to essentially decarbonize terraces at that scale. We initially did some feasibility work up in Rossendale. And again, for everyone's benefit, Rossendale is East Lancashire. We border with Greater Manchester just at the top, but a lot of people won't quite sure where it is. It is the 15th smallest local authority, so I'll forgive anybody for not knowing where it is or what it is. But we were essentially looking at how do we decarbonise these terraces. A lot of them are, now pre-1919, stone built, back to back. There's no space on the outside of these for air source heat pumps. You could wall mount them, but there's no wall to mount them on. They're straight out onto the road. Red border is the street, so we can't do anything externally. And the only real other option when we were looking through this piece of evidence is electric boilers. Coming from a fuel poverty background, that was not something that I was comfortable in pushing forwards. So, the spark gap as it is, the cost of between electricity and gas, we can't be running electric boilers with people's homes that, might have kind of set equals and push them further into fuel poverty. So we looked at ground source, and we looked at how an ambient loop system that's been trialled and tested in social housing around tower blocks for years and years, how we can transpose that onto terraces. Because the idea, our director always says that a terrace is a tower block on its side, and you kind of like, well, yeah, I can kind of see that. So we're looking at how we can do that, but we're looking at it in a whole system. So we're not only putting the heat in, we're looking at how you essentially upgrade the fabric of the property as well. And we're kind of going somewhat against the grain here. We're not going super deep retrofit. We're pre-sizing the heat pump and using the 5.8 kilowatt shoebox Kensa unit. And then we're designing the fabric retrofit to sit around that. So we're bringing the heat load of the property in line with the heat pump so that we're not being super disruptive, as we know that a lot of the properties, a lot of these terraces, a lot of work doing to it anyway. So we don't want to be showing them full of loads of wall insulation, loads of stuff. But again, a lot of them are small, so we don't want to encroach much into that space. Radius might need to good radius, 10 or like. On top of that, we're looking at a package of solar panels that will sit on the long roofs. And at the moment, we're working with our local DNO, Electricity Northwest, to develop a smart system that will sit within that and help us balance and aggregate on a local level. So the idea would be that the homeowner will own panels, but we would own the generation. And then we can essentially move electrons around to that kind of community and balance and aggregate on a really granular substation by substation level and kind of help address that spark gap in that kind of way. All of this is wrapped up in kind of a neat little bow on top. It's a no upfront cost cobble. So again, as Andy said, we're looking at investors. We're looking at getting this when it gets to scale. We essentially crowd in kind of that investment, and because everything's modular, everything's the same, everything's following the same due diligence, the same QA process, everything's following the same kind of roll through. When we go to deploy in different areas, we can then aggregate that, but then we can mobilize pension funds. We can look at the big heavy hitters, that patient capital, to get it out the door, so that we're not having to wait for loads and loads and loads of people in one area and kind of sitting everyone waiting on their haunches. And it means that we can then mobilize and keep going and then hit different areas and different terraces as we go through. And then built into the back end of that, again, is the community benefit side. Rossendale Valley Energy is a community benefit society. We set up for the benefit of the communities, and name suggests. So we're looking at how we make it usable, how we can produce people's bills down as much as we can, and then any profitability that comes out of flexibility or anything in terms of the electric system, we can then push back into either reducing people's bills further or community benefit funds for the longer areas. That's what we do want. But so we're very early doors with this. We are just close to the end of our Innovate UK funding, in which we've done 3 properties in Rossendale, and we've fitted them with all of the kit. Like I say, the course is in development, but it's making good headway, and we're looking at the future. Thank you.
Hi everyone, thanks to Hum for having me. I'm Peter Griffith, I'm from Regen. I'm Principal Analyst of these there. Regen is an organisation that's, I know from Rothham, with a mission to decarbonise energy across the world. And we do that for offering advisory services and analysis to get at the technical problems and the policy problems that are holding all these things back. I think the place to start on this question is exactly the question. That's why I wanted it to go before me. Exactly the question that Zero Terror Streaks is asking is, how are we going to decarbonize this home? We need to be asking that question in every single home in the country, and every home needs a plan. And at the moment, there are broadly two policy approaches for governments about low carbon peaks. So on the one end, we have individual e-pumps, so primarily boiler upgrade scheme and eco-funded e-pumps. They're going into individual paints. At the other end, we've got heat network zoning, and this is really large commercial heat network models. Both of these, great. I think they're broadly the right sort of thing we need to be doing at both of those scales. And in between, we've got a heat gang in the policy gap, where actually there are homes that don't really fit into either of those policies, which is exactly what the Net Zero Tertiaries project ECB is looking at. As one example. If we look at kind of the volume of these homes, we reckon there are about 1.8 billion of those homes kind of across the country. So these are homes where the space constraint is such that the individual e-pumps are really hard off. Some would say it's possible, some would say it's just a socially understood. There are also homes that are unlikely to be in e-network zone areas. If you look at e-network zones, they need those accolades just a moment. Actually, if you look at the pilot maps, even where there's a hospital or for a university campus that is that anchorage, they tend to stop before they get to that kind of row of deaths, terrace housing, which in a way is surprising that actually, if you look at these projects, the connection cost is in the orders of tens of thousands per individual loop, could be about 20k. It's greater to go with Scoff Ballbows. Scoff Dry Hebrew. Got a fat.
What's up to you?
So if you're having to justify an individual connection cost for an individual dwelling, and the heat demand of that small home is going to be so low, you can't really justify that for quick commercial use. So in this gap, we've got to look at addressing either can we make one of those solutions all palatable? There are some other things going on. And I don't think, key networks rely on a density. They're very expensive to do these connections. We can't say that they're the answer anywhere. And in some cases, it doesn't make sense. For me, the big question in the middle of that is one, can we adjust those policies? So, we're saying it might expand slightly if we say, well, these homes aren't going to have an air source heat, but an individual air source heat models are too small. So we need crowdfunding to cover that additional cost agreement in that zone. That would take off completion. But for lots of homes, there's this flexibility question that's kind of hanging over the fix for high ones. So thermal storage and big batteries offer a compelling case to say, oh, well, maybe this is the way to do it. It's a smaller unit, likely cheaper to install, more familiar. But the question around that is actually the long-term cost of that flexibility. Is that really going to deliver value? Or over time, are we going to really miss how efficiency? Across all of this, really, that kind of the point we need to say is there needs to be a strategic approach. At the moment, we need to have that vision of a low carbon need solution for every single home in the country. And we need a more strategic idea of how we're doing that. So when uncertainty in this eco and the old is really kind of chilling. Well, no, actually,